Okay, hello, I'm Joe. I work at a company called Cloudreach, where I do like full stack development, but they don't let me do any C++ there. So to let out all my repressed desires to do low-level things, I also have an interest in game development. I run a website called cpppatterns.com, and I also run C++ Edinburgh as well. My main credential for standing up here and talking to you all is that my Stack Overflow reputation, which I haven't actually been on Stack Overflow, like at least answering questions on Stack Overflow much recently, but it's now maintaining itself. So, so I'm really good at like automating things. So today today I'm going to be speaking about unique resource, which is a new type that's being proposed for the standard library. And kind of how I came across it and started using it myself. It's a very simple idea, but I'll give a bit of the background behind it basically. So the problem that we are trying to solve. So resource handles. Almost certainly you've dealt with resource handles before. It's a very simple concept, but you maybe haven't thought about them in a general way. So here's a kind of loose definition of it. So a resource handle I consider to be like an abstract reference to some resource. Typically you call some function that allocates something or gets some resource somewhere in some external system, and it returns to you a handle that represents that resource. Most commonly seen in C APIs. So as an example, you've probably seen this function before, fopen. It's a part of the C standard library for opening files. You give it the name of the file you want to open, some options, and it returns to you this file pointer, right? And exactly what's in that file pointer doesn't really matter. It just represents the file that you've opened. Later on in your program, when you're done with this file, you have to close it with fclose, right? So this would often be described as like an opaque handle, in the sense that, like I said, you don't really need to know what's in this pointer. It's what's the address of, what's actually in the file structure, who knows? It doesn't really matter. It just is an abstract reference. But they don't all have to be opaque. So as another example, I would consider this to be a resource handle as well, right? So I'm just calling the new operator to allocate some memory, and it gives me back a pointer to the memory that I allocated, to the objects that I allocated. And it follows the same patterns, right? Later on in my code, to clean this up, I have to then delete that resource handle. So same pattern, I'm allocating something, getting something that represents it, and then having to delete it later. In this case, it's less opaque. We actually know what that pointer is, but it's still a resource handle, I'd say. So the actual example that I was working with when I started looking into this, so this is from the Vulkan API, which is a graphics API, basically for controlling your GPU. Think of it like OpenGL, but better designed for modern GPUs. And the Vulkan API is full of functions that return handles like this, because most of them are like allocating something on your GPU, or maybe they're creating something on the CPU side that is somehow connected to something on the GPU and deals with communication between them. So functions that begin with create in the Vulkan API typically return a handle of some sort. So in this case, what I'm doing, this is just one example of it. I have a physical device which actually represents the GPU in my system, and I call create device on that, which returns this vk device object, which represents a logical device. The exact details of what that means, it's not really important for this, but what is important is that vk device is one of these resource handles, and later on in my code I have to call destroy on that handle, right, to clean it up. So note that this is not, this is clearly not just C. There's namespaces in here, and I'm calling a member function of a thing. So this is a C++ wrapper around the Vulkan API, but it doesn't go the whole way, I'd say. Like if this was a proper C++ wrapper, it wouldn't be returning me things like this. We expect something better in C++, so what is that? So the goal here. So this is a very common term in the C++ world. Hopefully most of you have heard of it already, but resource acquisition is initialization. is a very fundamental concept. It's not the best name ever because, well, first of all, it's hard to remember, but it also only really captures half of the story. The idea is that class types have constructors and destructors, and in what we like to do is in the constructor of a class type object, we would allocate resources that that object uses, and in the destructor, we would deallocate them. And because the calling of the constructor and destructor is tied to the lifetime of the object, the destructor is called implicitly when the object leaves the scope, right? So now if there's resources being created inside this device class, being allocated inside there, when it goes out of scope, they'll be cleaned up automatically. So this is kind of what I hope to have at some point. I want a device class which is effectively a wrapper around that handle that I showed a second ago. In its constructor, it creates the device handle in the same way that I did in the previous example. And in the destructor, which gets called implicitly, it's going to destroy the device handle. And then I no longer have to care about doing that. As long as this, well, I mean, so this is going to go out of scope at some point, so that's going to get destroyed and everything's good. So a property that I would like this class to have is value semantics, right? So the VK device handle itself, oh, and just to be clear, so I've called my class device, but when I say VK device, I'm talking about the one that's provided by the Vulkan API, which is the handle. So this handle type it has reference semantics by default. And what I mean by that is if you obtain one of these and then you copy it into another VK device, these two devices represent the same logical device, right? However, I don't tend to like this. I prefer types that have value semantics because most types in C++ operate under value semantics. And so what do I mean by value semantics? Well, I mean copying a thing with value semantics means copying the thing that it represents, right? So in this case, I'm declaring an int x to be 42 and copying it to y. These are now two totally separate ints. Pretty simple. Same thing's true for things that allocate resources within them. So it's the string here. I'm copying it into string 2. These don't represent the same string. They are totally different strings. This is value semantics. If I want reference semantics, I just use references, which are built into C++, right? So in this case, I'm declaring an int reference, xref, and this will reference x. And so if I modify x, it will modify. If I modify x reference, sorry, it will modify x, and vice versa. They are referencing the same object. Pretty simple stuff. So I prefer to use the built-in reference types to do this. But of course, sometimes you need references that have some extra semantics of some sort. So for example, shared pointer has reference semantics. That's because it's a type designed specifically to do like reference counting on dynamically allocated objects. And like reference wrapper is another example. But in most cases, I can get away with just using reference types. So what does it mean to implement value semantics for a type? For a type that owns some resource? Well, I'd say, this is just a general simplification of the whole thing. So if I'm doing this, copying should either allocate a new equivalent resource and then own that instead. Which is what happens in the case of string, right? If I copy a string, it allocates memory to store the characters in, copies the characters across into that new memory, and then it owns that instead of owning the original memory that was in the original string. Or you just don't allow copying, right? I mean, that's a great way to avoid ending up with references to the same resources. If you can't copy them, it's not going to happen, right? And then moving. So in case people aren't aware about moving, it's effectively like a optimized copy in the case that you're copying from a temporary object. Although you can use std move to basically make an object appear like it's temporary and then copy from it. And the reason that's optimized is because you don't actually have to copy the resource from that object, you can just steal it because it's a temporary and the temporary is not going to need it anymore, right? So in the case of moving, we just want to pass ownership of the resource to the new object. For my device type, though, I've decided to go with copying is not allowed, partly because it simplifies the whole problem, but also, like, what does it even mean to copy a logical device, like a logical GPU? So it's like, I don't even want to care about what that means, so I'm just not going to do it. I guess it would mean something like creating another logical device that has the same properties, but unless it, I don't know, it just doesn't sound like a sensible idea to me, so I'm not going to allow copying. Another thing that I would like is I would like to be able to implement my type device with the rule of 0. So in case you haven't heard of this, this was originally called the rule of 3. And the idea was that if you implemented a destructor for a class, you would also have to implement the copy constructor and copy assignment operator, because in your destructor, you're probably having to clean up some resource, which means you need to deal with that resource in your copy constructor and assignments. That then became the rule of 5 once we got to C++11 because of move constructor and move assignment. So if you were doing those 3, you also had to do those 2 as well. But then we realized as a community that in fact we can use types that represent the ownership semantics we want and avoid ever having to write any destructor or any copy constructor, assignment operator, move constructor, move assignment by using types that represent those semantics. So a common type that's used for this is like unique pointer or share pointer, whatever, like one of those. Which, when they are copied or when they're moved, they provide the semantics we're expecting. And so if we were to default our copy constructor or move constructor, for example, the default version of those would do what we expect without us having to implement any logic to do with transferring ownership or managing any of that stuff. So kind of what I'd like is some type. This is the goal here. I need some type which as a template parameter takes my VK device, and this is so that I could, this is the general type, so I could use this anywhere. It doesn't have to be wrapping just my VK device, it could be wrapping any other resource handle as well. And in my class, when I initialize that, I'm gonna, of course, give it the value of the handle as the first thing, and then I'm also gonna give it a deleter. In this case, it's a lambda function, which takes that handle and then calls destroy on it, right? And I'm deleting the copy constructor. I would also delete the copy assignment operator as well. I'm defaulting the move constructor, right? And so the plan is to have some type where I can write this and I never have to write any other logic around managing that handle. Okay. So for brevity in the rest of the slides, I'm going to omit most of this. If the constructor is ever a bit different, I'll put the constructor in, but I'm going to omit the defaulted and deleted constructors. Any questions so far on everything that I've covered? No? Okay. So, failed attempts. So when I was like trying to deal with this, I was like, well, maybe I can use things that already exist in the standard library, right? So the first thing I thought about was stud optional. So let's just write out our class as though it's just containing the VK device inside, and I have to implement a destructor, and it's going to call destroy on that handle, right? The problem with this is that when I move from this, oh, of course, imagine those things I'm omitting are there as well. When this is moved from, the moved to object will have a copy of the device handle, and then the destructors on both of those objects will end up both destroying that handle, and we basically end up double destroying it, which is not a good thing. So we need some way of, when a move happens, saying that this is no longer there anymore. So I was like, well, stud optional is for representing things that might be there or might not be there, so let's just go with that. So we put, and if you haven't used it yet, std optional is new in C++ 17. But before that, you can use it as std experimental optional, so you could use it prior to C++ 17 as well. Sorry?
Can you use my one with the monadic?
Oh, you can use Simon's version of std optional, which supports the monadic monadic interface. Let's say I put a std optional in here. My destructor now needs to go, does this std optional contain anything inside it? Which is what this will do. It implicitly converts to bool to tell you whether there's something inside it or not. And if there is something inside it, I'm going to call destroy on that thing, right? So now the hope is in the moved from object, it will no longer have the device handle and it will no longer destroy it. So first problem, which is not a major thing, but it kind of goes against the rule of zero. I'm having to implement a destructor here to deal with this. But there is a second problem. So you might assume that this will work, right? Surely if I'm moving from this, it'll steal the device handle from this class, and then only one of them will get destroyed. Does anybody know why that's not the case? Why isn't this just good enough? Yeah.
Try and access a move from things undefined heap.
Well, so I won't be, right? Depends. So you're thinking of the device handle as being moved from, and so I'm checking it here?
Yeah, that's what I'm saying.
Right, okay. So I guess that sort of gets to the point, which is that moving from a std optional doesn't actually leave the std optional empty. So I guess it makes sense when you think about it, but instinctively I was like, well, surely moving from a std optional leaves the std optional empty, but actually it doesn't. It leaves it with a thing inside it. It's just that thing that's inside it has been moved from. So they're both non-empty, but one of them has a moved from object inside it. So it wouldn't actually be a problem because the std optional itself is not in an invalid state. It would only be if I was actually accessing the device handle inside it that there'd be a problem. But this is a problem because moving from std optional does not make the std optional empty, just moves the contained object. In this case, moving my contained object, which is that device handle, is just the same as copying it. So we've just ended up with two std optionals that have the same object inside them, same value. So we'd have to write a move constructor to deal with this, a move constructor that will like set the optional to empty after it's done. Basically, it doesn't provide the semantics we need. So second thing I think about, what we really want here is unique ownership of this resource, right? So we should use unique pointer. That's what that's for. However, so here's a kind of pictorial representation of unique pointer. It's an object that contains a pointer inside it that points to some other object somewhere else in memory, right? And by default, it expects that this object has been allocated with new and will be deleted with delete, deallocated with delete. However, it does support custom deleters, right? So we don't have to make it delete this with delete. We can make it do something else. So as an example, next thing I tried, you've still got your VK device handle in here, but you've also got next to it a unique pointer, which is a unique pointer to a VK device, but it has a custom deleter, which is of type std function, where the function takes a VK device pointer and returns nothing. And that's my unique pointer there. And then I initialize them. So I initialize the handle itself the same way I always have been so far, by calling my create device function, doesn't matter what that does, which returns the handle. And then I initialize the pointer by passing it the address of my handle and a custom deleter, right? And that custom deleter has the same signature. It takes a pointer and then calls destroy on that. I've just realized that should be dereferenced there, but whatever. You get the point. So problem one is this is not as neat as I was hoping for, because now I've got these two things representing the same thing. But there's a much worse problem than that, which is that I'm taking the address of this device handle, and after a move, this object, the original object, will eventually disappear, and this device handle will no longer be valid. This address will be pointing at something that doesn't exist anymore, right? So after a move, the unique pointer in the move to object will be pointing at the device handle in the move from object, which is going to disappear very soon, which is not good. Not good at all. So my next thought is, don't I want something that like sort of combines the two? I sort of want a unique pointer crossed with a optional. So it's like it has unique ownership and it stores the handle directly inside it. It's not dealing with like pointers to dynamically allocated memory or whatever. So a kind of hidden feature, one that you probably shouldn't use ever, of unique pointer is that the custom deleters allow you to override what's stored inside the unique pointer. So back to my pictorial representation, this thing that was a pointer in my previous diagram, you can make it whatever you like. All you have to do is whatever type you're providing as the custom deleter, in the previous example it was a step function, whatever type that is, if it has a type def pointer, that will get used as the type of the contained object, right? And the way that's defined is it does remove reference on the deleter, and then it gets the pointer type def from that. If that doesn't exist, it just does t star, which is how we had the original. This is why it's like this in most cases, because in most cases there is no custom deleter, and so t star is just vk device pointer, right? So that's what this is. This deleter, this pointer has to, this pointer type, it's not an actual pointer, it just can be anything really, but it has to satisfy the nullable pointer concept, which effectively means that you can assign null to it and you can compare it with null, and things like that. So why don't we make our unique pointer store a std optional? So what we can do is we can create a custom. You should start to feel uncomfortable, basically. So you can create a custom class device deleter, which is going to have a type def pointer, which is std optional vk device, and now my unique pointer is storing a std optional inside it, right? Which is great, except for the fact that I said it has to be a nullable pointer, right? Std optional is not a nullable pointer. So what we're going to do instead is we're going to write our own type that's like a std optional, but there's also, you can assign null to it. So optional does have a thing called null opt, which you can assign to it to empty it, but you can't assign null pointer to an optional to empty it. So std optional is not a nullable pointer. So we're going to make our own type. I've actually censored out the code here because it was so horrible. I was going to put it in, I was like, but I don't want people to actually copy this code, so I just blurred it. Basically, what it did is you should never do this. It inherited from std optional and added things to allow you to assign null pointer to it and compare to null pointer. It was horrible. But it did actually work. But you don't want to do this every time you want to deal with this, right? So, if only we had a value wrapper like std optional, as in it actually contains within it the value rather than having a pointer to somewhere else. But with the unique ownership semantics of a unique pointer, when you move from it, you move the resource, right? That resource is no longer owned by the original. Unique resource, the whole point of the talk. This is going to seem so anticlimactic because it's so simple. So unique resource is a new type that's been proposed for the C++ standard library. In the paper, it's described as a universal RAII wrapper for resource handles. The paper in question is this one. Generic Scope Guard and RAII wrapper for the standard library by Peter Summerlad and Andrew Sandoval. And there's a link to it here. This is the latest revision of that paper. So how does it work? This is how simple it is. Inside my class, I have a data member, which is a unique resource of VK device. In my constructor, I initialize it with I create the handle and initialize it with that, and I also provide a deleter. And the deleter just takes, I think you could take a reference, but I'm just taking a copy of the handle. It doesn't really matter in this case because it's lightweight, it doesn't cost much to copy it. And then call destroy on it in the deleter. And with my defaulted move constructor and assignment and my deleted copy constructor and assignment, I don't need a destructor. This is it. This is all the code I need, right? This handles everything. None of the horrible stuff from before. So some operations that this type supports. It has a unique pointer-like interface. So you can call get on it. If you call get, it returns the resource that's inside, if you want to actually deal with that resource. If the type that it's containing is a pointer type, you can also do dereferencing on it as well. It's just like you could with a unique pointer. So in fact, you could quite easily implement unique pointer with unique resource, right? You just have a deleter that does delete of the thing, and then you'd be able to use it in the same way as well. You can also reset a unique resource, which calls the deleter on that resource, but future calls to reset or the destructor won't do that, right? So once it's been deleted or reset, it won't get deleted again, which is obviously what you expect. You don't want to double delete the same resource. Or you can release, which works exactly like it does with the pointer types. It basically says this object no longer owns this resource, so it won't ever delete it in the future. Okay. Another thing that's provided is a factory function like this. It's called make unique resource checked. And this is useful for if you ever want to create a resource, but it's possible for creating that resource to fail in some way. And when it does, it returns you a value that represents that it failed. In this case, this example is with fopen again. If this file doesn't exist, fopen returns a null pointer. So what we're saying here is, so we're getting the handle here as normal, the handle to the file. The deleter is going to be fclose. But if the value we get back from the fopen is a null pointer, then it's not going to attempt to close it later. It's never going to attempt to call this deleter on it. Right? I feel like it would be quite useful to be able to provide a function there that, in case you needed to do some more complex checking or something like that, but I don't think that's in the proposal. So separate from unique resource, the paper also proposes these types. There's scope exit, scope fail, and scope success. These are just scope guards, and the way they work is you pass them a function. In this case, I'm passing them a lambda, and that function will get called in certain situations. Scope exit will call its function when it goes out scope, or if an exception is thrown. Right. Scope fail will only call its function if an exception is thrown, and scope success will only call its function if it goes out scope gracefully rather than via exception, right? So these are useful as well. So the current status of this proposal, it's currently on revision 9, which is quite a high number for revisions of proposal to go into the C++ standard. So I messaged Peter Summerlad just before this to check what his view of the status was. And he said basically it's unlikely to be in C++20, but he may attempt to get just unique resource in. So he's going to write a paper to do that, or may write a paper to do that. So if it does end up in C++20, then it will be just unique resource. most likely. Otherwise, it's probably going to end up in a library fundamentals technical specification, which what that means is at some point after it's been added to that technical spec, you'll hopefully see it implemented by standard library implementers as std experimental unique resource. And then that means the library writers can implement it in advance. And then when it does get merged in, hopefully for C++ 23 or whatever, they've already got a working version that they can just remove the experimental namespace. So Peter Summerlad also did a talk on this, which goes into much more detail than I just went into. But also, this proposal has been in the making for like 5 years. So he also talks about the struggles of doing that and keeping it up to date with the changing standard and all the difficulties of writing such a simple type. You'd expect it to be easy, but apparently it's not. So I recommend watching that. It's only a month ago this was online, so it's very up to date. However, it's a proposed type, so obviously you can't use it yet, right? Well, no, there are some implementations on GitHub. This one is the main one. I believe this is up to date with the latest proposal, the latest paper. So if you check out this link, you should find both unique resource and the scope guards in there. There is another implementation, but as far as I could tell, this hasn't been updated in quite a while. So it's like an old version of the paper. But you could use either of them. So there's like no real reason not to start using this now, and I'm using it with my Vulkan code, and I hope that it will be added to C++ very soon. And that is it. Questions? Thank you. Anything? Yeah?
If you go back to the
How far?
the check one.
Okay.
So this passing f close is a function parameter.
Mhm.
You also pass a function object which with a call operator which calls f close as a template parameter, so you're not to store a function pointer alongside.
I believe you can pass anything there that's callable and takes the whatever resource
Yeah, but
type
then
it
you
is.
need to store it alongside the resource.
Right.
Whereas
Okay.
if it's a template parameter, you wouldn't store it.
I'm not sure honestly, so I have to check. Okay. Have to check. See. Any other questions on this? Yeah.
Are there any limits on just what you can put inside these resources? Could you put in instead of
Yes, you could. What would that mean?
Stop it.
You could contain a std unique pointer, which contains a std optional. You could go crazy. And there are some requirements on the type, but it's pretty relaxed. I can't remember exactly what the requirements are, but it's just things like whether it's copyable or not, and things like that, rather than like specific expectations on the interface or anything like that. It's meant to be a general purpose wrapper. Anything else? Oh, another one for Simon.
Maybe I should just watch Peter's talk, but
Mhm.
why did it say 9 revisions?
There's just, if you check the paper, like at the top he's listed like everything that's changed over the years. And I think it's a mix of things. It's like, well, I think partly it's just like having the time to keep it updated. But like there's been constantly like suggestions to change things. The language has been changing. So updating it to match that, just things like that, really. Anything else? If not, thank you.